We now will have a look at the monitored reap system test, the power test. The power test was specially designed for the MR-Cube, but can also be performed on the other systems. We do a left-right comparison. We can select or the amount of repetitions or an amount of time. Important is that we create fatigue. So with a lower weight, we need a higher amount of repetitions, and with a higher weight, we can get a lower amount of repetitions. The range of motion acceptance means how much of the range of motion you would have to do to account that as a real repetition. We do 1 repetition for the range of motion, and we start the test. 10 repetitions. The instructions are go up and down as quick as you can. All the way, 10 repetitions. Show us your maximum speed. Of course, we know that the speed going down is not an eccentric speed, but it's more the gravity helping you. The involved side, same instructions, 10 times, up and down within the range of motion, as quick as you can. And what you see, of course, a little bit fake, we get fatigue, it's getting more heavy, it's difficult with the same weight to make a higher speed. And that's exactly what we are looking for. The weight is all the repetitions the same. The only thing changing is the amount of speed. Directly after the test, we get our results. We see that we can have a look at the range of motion, and the right lower corner we can select to have a look at the involved side data or have a look at the non-involved side data. We can have a look at all the numbers, but maybe it's easier to have a look at the total work and the total power. What did we perform in total? And we see that there is a deficit in total work between involved and non-involved. The speed has a legenda. Purple is a higher speed, in this case above 60, but we can change that. If it's all purple, we need to set the speed limits or the colors different. And we can see that there's still at the involved side a deficit with the non-involved. In involved, we saw the last repetitions totally in green, low speed. And of course, it's easy to have a look at the average, 76 versus 54. So in the involved, the average concentric speed was slow. Then we get all 10 repetitions, and in this graph we can have a look at the acceleration. The first part of the movement, concentric, this is 20% of the movement, and it's the time to do the 20% of this movement. Altogether, we can see the average acceleration time. Also over here, eccentric is not giving us a lot of information. We are more looking at the concentric speed. If we have a range of motion and we want to see a larger percentage of the range of motion, how much time did we use to do 40% of the range of motion? What's the average in non-involved and what's the average in involved? The average of the 10 times 40% of the range of motion, with the question or the task for the patient to do this as quick as possible. In the summary, we just have a look at the second and the last, because that's where we say would be the most information. We can again change the scale for the colors. We get all the numbers, the averages, and if we ask to print a report, we also get the summary of the second and the last repetition with all the numbers on paper.